Hi there, Rachel Chase here, and in this final video of our confidence interval series, we'll explore calculating confidence intervals and estimating sample sizes for dealing with population proportions. Now, recall from the previous introductions that anytime you're calculating an estimate for a population proportion, it's because proportions are qualitative data. So this is one of our first real tastes of getting to calculate information with qualitative data instead of quantitative data. The margin of error this time is given in a very similar formula, also using the z-score, so z alpha over 2 that we learned about when sigma was known, times this time it's the square root of p hat q hat over n. So p hat, if you recall, is equal to the sample proportion, and q hat is the complement of p hat. And of course is still your sample size. Let's take a look at an example here. A survey of 145 randomly selected students at one university found that 301 think that there is not enough parking on campus. Construct a 90% confidence interval for the proportion of all students at this university who think that there is not enough parking on campus. So what information have they told us? Out of 345 students, 301, we call that X, is equal to the number of people who think there is not enough parking. X and N put together, since they didn't give us a percentage, is equal to P hat. So P hat is 301 over 345. That means that Q hat is equal to 345 minus 301 is 44 over 345. Since those are not very pretty decimals, we're going to leave those as is for now. For a confidence level of 90%, that means that alpha is 0.10, so alpha over 2 is 0.05. Now, the choice is yours how you wish to approach something like this. Since we've just done a few with the calculator, let's see how this works for the z proportion interval function this time. So if you go to stat tests and scroll down, you're going to look for, this is called a one proportion z interval. So we're going to select the first option here, one proportion z interval. X is 301, that's the number of people who said there's not enough parking. N is 345. At a 90% confidence level, let's see what this gives us. So that means that, we have our interval, so let's calculate our margin of error, 0.902 minus 0.84292 divided by 2 gives us a margin of error of 0.029. So what on earth does all of this imply? So if our margin of error is right around 3%, and our proportion, so that means that 0.843 is our lower bound, and it's the estimate for P, the population proportion, that between 84% and 90% of students believe that there's not enough parking on campus. So what have we found here? It's the same concept that we talked about earlier, but now we've taken a sample of 345 students to answer basically a yes or no question. Yes, there is parking. No, there is not enough parking, right? So the idea here is that when you get that interval, those are actually percentages. So we can be 90% confident that between 84% and 90% of students do not believe there is enough parking on campus. If instead you prefer to do these the by hand method, then feel free. You can either use the inverse norm function to get your z-score, so that would have been a 0.05. So if instead you did this, you could have used a z-score of negative 1.645. and then that would have given you the same interval here. Let's take a look at another example. In a recent study, 820 American adults were surveyed, and 61% of them said they would travel less this year for non-business trips than last year. Construct a 95% confidence interval for the true proportion of adults who said that they would travel less this year for non-business trips. So let's go ahead and try this one by hand since the numbers are a little bit nicer in this case. We have a sample of 820 Americans. 61% said they would travel less this year than last year. So that means that they're telling us p hat is 0.61. That means that q hat is 0.39. Construct a 95% confidence interval. So alpha is 0.05. Alpha over 2 is 0.025. You'll notice we use a lot of the same numbers pretty repetitively. And that means if you look it up on the table or if you use the inverse norm function, that your z-score is equal to 1.96 or negative 1.96. So our margin of error equals 1.96 times the square root of p hat times q hat divided by 820. As far as how you would type something like this in, if you're a little intimidated by the amount of stuff going on, start inside the square root and work your way out. 0.61 times 0.39, divide that by 820, and then take the square root of that number. Don't try and type that in. Use the second A and S because that plugs in what's on the line above it, and then that gets multiplied by the z-score. So this gives us a margin of error of 0.033. That means that about 3% of a margin of error. So from there, to calculate your confidence interval, take your your sample proportion, 0.61, and add or subtract the 0.033 that you have. This gives us, when we subtract 0.577, which is less than the population proportion, which is less than our maximum of 0.643. So according to this, how would you interpret that? 95%, so we can be 95% confident that somewhere between 57.7 and 64.3% of adults would travel less this year for non-business trips. So whether you like to do these in the calculator or if you like doing them by hand, such as this, the choice is entirely up to you. There is one final thing we should look at here, and this is similar to what we did in the second video when sigma was known, is how do you calculate a minimum sample size requirement for proportions? Why might this be useful? We went into that earlier, just to make sure you sample enough people. There's two things that can happen. When an estimate is known, in other words, when you have an idea of p hat, and when an estimate is unknown. So if your estimate is known, your sample size is given by p hat times q hat times the z-score divided by the margin of error squared. If your estimate is unknown, then you use 0.25 as a placeholder. And for each of these formulas, they are provided to you on the formula sheet, similar to all of the other ones. We can take a look at that before we wrap up this video. Please make sure you take a look at what is given to you because, again, you don't have to memorize these things. So with each of these in mind, let's do an example. What is the minimum sample size needed to estimate the percentage of adults who have consulted fortune tellers with 98% confidence within 3% of the population proportion? A previous poll suggests that 15% of adults have consulted fortune tellers. So right away, they've told us that we want to be 98% confident. We want to estimate within 3%. And previous information, that means p hat, suggests that 15% of adults have sought a fortune teller. Well, if they tell us p hat, that means we can use our first equation, which we have to find q hat for, is 0.85. So our sample size is equal to 0.15 times 0.85 times our z-score, which we have to find real quick. So use inverse norm or your table, whatever makes you happy here. So that means alpha is going to be 0.02, so alpha divided by 2 is 0.01. So we have a z-score of negative 2.33 if you round that, or positive 2.33, whichever. When you square a negative number, it becomes positive anyway, divided by our margin of error, 0.03, all squared. So same thing we did before, take this one step at a time. We have here 2.33 divided by 0.03. Then square that number and multiply by p hat times q hat. So this gives us a sample size requirement of, round that up to the next whole number, we need to sample 770 people in order to estimate this within 98%. Now, when would there be a case that you use the other formula? If instead, if we revisit this question and it just says, what is the minimum sample size, based on that information, but you notice we have no previous information, then everything would be the same except for that prefix. We would be using the equation with the 0.25. So n would equal 0.25 times 2.33 over 0.03 squared. So repeat that process. And as you can see, we have a much, much bigger requirement for the number of people that would have to be surveyed. So we would need approximately 1,509 people. And that's because we do not have a previous estimate to work from. As far as confidence intervals go, the process is the same for each. So once you learn the process and you get familiar with which formula is appropriate, whether it's a t interval, a z interval, or even a proportion interval, you should be pretty comfortable with how to approach these. There's not a different concept for each. Again, it's all the same idea, just really practicing selecting the appropriate formula in the appropriate case. Thanks for watching.